Working on inequalities in 3-1. And we're going to start by talking about that the inequality, the Pac-Man right here, is always going towards the bigger number. It kind of like eats the bigger number if you want to think about something. So if you have an inequality, you can add something to each side and it'll stay the same. So 11 is still bigger than 8. You can add again to each side. 13 is still bigger than 10. If you subtract something from each side, let's subtract 6 from each side. 2 is still bigger than negative 1. And if you want to subtract again, we could subtract 2. 0 is still bigger than negative 3. Oh, what happened there? Okay. So if you add or subtract to both sides of the inequality, it's true no matter what. And if you need to solve, you would just subtract the 29. We need to isolate this g. It remains the same because adding and subtracting the inequality is true no matter what. So 68 minus 29 is 39. G is less than or equal to 39. And then you're going to be graphing, well, I'll just wait for that, but okay. The next one, minus 21, so we're going to add 21 to each side to isolate the y. So y is greater than 28. Like this means g, the solution set for g, are the numbers such that g is less than or equal to 39. That's the most precise way to write the solution set. If you're going to show that x is less than 7, because 7 is not part of the solution, less than numbers work in this case. It's easier to draw, but either is totally fine. I'm going to go with the arrow above after this for obvious reasons, but this is totally we have that 4 is part of the solution. So we're going to go ahead and take these words and put them where they should be. Fewer than is the same thing as less than. So those would both go there. At least, if I have at least $8, I could have $8 and I could have more. So I could have $8 and I could have more. So I have at least $8, greater than or equal to $8. At most means if I have at most $10, I could have $10 and I could have less. Less than or equal to is what that one is. No less than. If I have no less than $10, that means I could have $10 and I could have more than $10. Greater than or equal to. Hold on, this one I just put in the wrong place. No less than 10. I could have 10 and I could have more. Just greater than is right here. More than is the same as greater than. And if I have no more than $10, it means I could have $10 and I could have less. So this is no more than, and this is no less than. Okay, that could be tricky. Hopefully not anymore. I always like to think of money when I'm trying to think about what it means. 3 times a number, I'm going to write that right now. 3 times a number, any letter will do, is more than. Is more than. So 3 times the number is greater than the difference of twice that number and 3. So I'm subtracting twice that number and 3. So if I want to solve this, I'm going to put all my letters on one side. And I get x is greater than negative 3. And then if I'm going to graph that on a number line, you probably want to start at 0. And my negative 3 would have an open circle because there's no equal to below that. And then it's greater than, so my arrow goes to the right. One-fourth a number is less than 5 minus the number. So we're going to add x to both sides. And an x is the same thing as a 1x. I can put a 1 in front of all these, same thing. So I have 1 and 1/4 x is less than 5. I'm going to rewrite that as 5/4 x because I think it's easier. Fourths, you can multiply by the reciprocal. And as long as you're multiplying by a positive, things shouldn't change. We're going to get to the negatives in just a minute. So x is less than 4. It's the same as 5/1. Cancel the 5s. And then on your number line, we have an open circle with an arrow to the left. If we multiply both sides by 4, do we get the same thing? So is 36 still greater than 12? Yep. So that works out. If we multiply both sides by negative 2, do we get the same thing? Is negative 18 greater than negative 6? No. Think about your money. You'd rather be 6 in the hole than 18 in the hole. If we divide both sides by 3, do we get the same thing? So 9 divided by 3 is 3. 3 divided by 3 is 1. Yep. And if we divide both sides by negative 1, do we get the same thing? Is negative 9 greater than negative 3? No. Therefore, when you multiply or divide by a negative, you need to flip the inequality. I like to think of it as worlds and negative worlds. And if you in positive worlds here, 2's are bigger than 1's, 3's are bigger than 2's, 4's are bigger than 3's. And if you go to the negative side, the opposite happens. You'd rather be $1 in the hole than $2 in the hole. So negative 1 is bigger than negative 2. So if you're ever changing worlds, which is done by multiplying or dividing by negative, you have to flip that to make it still true. So negative 18 would be less than negative 6. So the minute I multiply by negative 2, I'm flipping my inequality. The minute I divide by negative, I flip the inequality, and then it will be true. Like a rule. You're ready to put. So in this case, to solve for x, we would multiply by 12. To undo that, divide by 12. 12 is the same as 12/1. On the left, we're left with x. We did not multiply by a negative, so we do not flip the inequality. And before I get too excited and multiply, I can reduce this to a 1 and a 6, so it's 18. So x is less than or equal to 18. If you're still going on your number lines here, you need to count by 1. But that would be a closed circle and an arrow left, less than or equal to. All right, this is written twice. So we're going to divide by -3. The minute you multiply or divide by a negative, you flip your inequality. So I have W, and I flip, and -9. Now, if you're feeling concerned that you did this right, let's pick a number and plug it in and make sure it works. So here's 0. Let's count by 3s. How's that? So I've got an open circle at -9 and an arrow to the left. It's a number smaller than -9. So 10 is a pretty easy number to plug in. -10 should work. It's in this shaded part. So let's check. -3 times -10, is that greater than 27? And yes, 30 is greater than 27. So we did it right.